Angle. Look at this figure. How many rays can you see? OA and OB, right? So these are two rays coinciding on each other. They have a common point of origin, O. Now watch. Now do you see this distance between OA and OB? An angle is formed here at the origin of the two rays. This meeting point, O, is called the vertex. The angle is represented like this, angle AOB or angle BOA. The angle is always written with the vertex in the middle, see? OA and OB are called the arms or sides of the angle. Now this distance here between the two rays is measured in degrees. Depending on the distance they form, the angles have different names. Let me tell you about them. Names of angles according to their magnitude. I am going to move arm OA to see the different types of angles it forms. Now, what is the distance between OA and OB in this position? No distance, 0, right? That is, no angle is formed. So, angle AOB is a 0 angle. Now look at this position of OA. An angle is formed. Let's measure it using a protractor. Angle AOB measures 60 degrees on the protractor. An angle less than 90 degrees is called an acute angle. Here angle AOB is 60 degrees and so it is an acute angle. And so are these. Take a look. Now let's check out this one. It measures exactly 90 degrees. An angle measuring 90 degrees is a right angle. Angle AOB is equal to 90 degrees. It is a right angle. Now check this out. The protractor reads 120 degrees, beyond 90 degrees. An angle more than 90 degrees but less than 180 degrees is an obtuse angle. Here angle AOB is equal to 120 degrees and so it is an obtuse angle. Take a look at this. All these are obtuse angles. Now see this. Ray OA falls on a straight line with OB. Protractor once again. 180 degrees on the protractor. An angle measuring 180 degrees is a straight angle. Take a look at this now. Protractor shows that the angle AOB is 270 degrees. That's more than 180 but less than 360 degrees. That's what we call a reflex angle. More than 180 but less than 360 degrees. Now watch. Hey, ray OA is back to where it started from. It has traveled one complete circle, 360 degrees. Friends, on the face of it, it looks like a zero angle, but don't be confused. Zero angle is when the ray or line has not traveled at all. Here OA has traveled one complete circle, and so AOB is a complete angle. Congruent angles. You see these two rays OA and OB forming angle AOB. Now let me draw another ray OC like this. So two angles AOC and COB are formed here. I am going to measure angle AOC and COB using a protractor. Are they the same? Oh yes, They are 45 degrees each. Here's another pair. Angle XYZ and angle PQR. Let's measure them. Yes, both are 90 degrees each. What is common in both the figures? Both the angles in each figure are equal in measure. 45 degrees in the first figure and 90 degrees in the second figure. Such angles are said to be congruent to each other. Complementary and supplementary angles. Friends, watch this. In this position, let me measure AOC and COB using a protractor. Okay, 45 degrees each, sum equal to 90 degrees. Now watch as I move ray OC upwards. Let's measure AOC and COB now. "60 degrees and 30 degrees. Sum equal to 90 degrees. One more try as I move ray OC. AOC is now 89 degrees and COB 1 degree. Sum equal to 90 degrees. Friends, in this way I can move OC to have 90 combinations such that the two angles AOC and COB total to 90 degrees. Angles AOC and COB are called complementary angles as the sum of their measures equals to 90 degrees. Friends, now a contrast. Watch. I am going to move ray OA. Now let's measure angle AOC. And now COB. Totals to 180 degrees. Now I am going to move ray OC again. Measures of AOC and COB total to 180 degrees again. And yet again 180 degrees. Two angles are said to be supplementary if the sum of their measure is equal to 180 degrees. Angle AOC and COB are supplementary angles. Adjacent angles. Friends, look at this figure. Angles AOC and angle COB. They lie next to each other with a common arm OC. Adjacent means next to. So these two angles are adjacent angles. When two angles lie on opposite sides of a common arm and have a common vertex, they are known as adjacent angles. Note that the adjacent angles need not be equal in measure. Linear pair. See this figure. Angle AOC and angle COB are adjacent angles, right? Let's measure these. AOC measures to 120 degrees and COB measures to 60 degrees. So we have two adjacent angles that are also supplementary angles. They share a common vertex, O in this case, and a common side, OC. These two angles form what I call a linear pair. Vertically opposite angles. Take a look at this figure that I'm drawing. Here lines AB and CD intersect at a point O. As a result, two pairs of angles are formed. See this? This is the first pair marked as A. The angles are opposite to each other. Similarly, here is the other pair marked as B. Again, these two angles are opposite to each other. Angle AOC and angle DOB are vertically opposite angles. Angle AOC is equal to angle DOB. Similarly, angle AOD and angle COB are vertically opposite angles. Angle AOD is equal to angle COB. Interior and exterior of an angle. Look at this figure. Confused? The green colored area shows a part of the interior of angle COB. Rays OC and OB are infinite, is it not? So the interior of the angle is also infinite. Point L lies in the interior of the angle COB. The red colored area indicates the exterior of angle COB. The exterior of the angle is infinite. Point M lies on the exterior of the angle COB.
Let us summarize what we've learned in this learning unit.